For the beginning of lesson 12, we are going to begin to understand the slope-intercept equation for a line. So slope-intercept form is y equals mx plus b, where m is your slope and b is your y-intercept. And when you graph this, it's going to give you a straight line. And if you were to draw lines coming straight down off of your straight line, you are going to form similar triangles. And what that means is that the angle measures coming off of the lines of both triangles that form both triangles will be the same. So this straight line here going from A, D, B, so this one here is your linear graph. And then they drew these lines coming straight down off it in two different spots. So when you draw any line, I can draw another one here and another one here. All of these angles are going to be the exact same measurement. And I'm creating triangles that are similar, and therefore their sides are proportional. So also your rise over run, which is your slope, that is proportional as well. So because that rise over run creates the sides or the top part of that triangle there. So all of that picture there tells us is that the rise over run ratio, so our slope, will always be equal and the triangles will always be similar. All right, so also, if you didn't have a graph and to find rise over run, you have to use your slope formula, which is y2 minus y1 over x2 minus x1. And remember that ordered pairs are given to us in the form of x, y all of the time, every single time. That's the form. And your first point would be the number 1, so x1 and y1. And then your second point will be the 2's, the x2 and the y2. And then you plug those numbers into this formula to find the slope. So for this example here, we're given three different ordered pairs. We only need 2 of them. So we can pick which 2 we want to use. And I'm just going to use the first 2. I'm going to use A and B. So if I wanted to follow suit with this formula, we have y2 minus y1. So y2, y out of my second point would be this here. That would be 8. And the formula says minus. Y out of the first point would be this 0. And then at the bottom, at the denominator of this, we'll have x2 minus x1. And that means x out of the second point, which would be this 4. Minus, because that comes from the formula, x out of the first point, which is 0. And then we go and simplify this down. So 8 minus 0 on the top is 8, and 4 minus 0 at the bottom is 4. And 8 divided by 4 is 2. So the slope of that line is 2. Now, if we wanted to just double check, I'm going to use B and D here, and I'm going to do y2 minus y1. So I'm going to have 4 minus 8. Then I'm going to do x2 minus x1. I'm going to do 2 minus 4. So 4 minus 8 is going to give us negative 4. And 2 minus 4 is going to give us negative 2. And when we divide two negatives, we'll get a positive. And 4 divided by 2 is 2. So different points, but we still get the same answer. Now we're given these 3 equations and we need to figure out if they're all linear. And if they're all linear, they can all be written in the form of y equals mx plus b. So looking at this first one here, we have, if I write y equals mx plus b, this one is already written in that form. So that one is definitely in linear. There it is, a linear equation. This one is not in the form of y equals mx plus b. I need it to be y equals, so that minus 2 can't be there. So I'm going to move it to the other side. So opposite of minus 2 is going to be add 2. So I'm going to have y equals, and then I have my x, and 2 plus 2 is going to be a positive 4. So now does this look like mx plus b? Yes, it does. The only thing it's missing, it doesn't have a number there for m, but when we don't have a number in front of x, it's really a 1. So yes, this one is in linear form as well. And then here, again, it's not solved for y, so we have to solve it for y. So I'm going to get rid of that 9. It's positive right now, so I'm going to subtract it. And I can't do 3x minus 9, so I'm just going to write 3x minus 9. And these guys would cancel, and I would be left with 3y. And then we have to divide both sides by 3. So this side we would just have y. And then 3 divided by 3 here would be 1, so we would just have 1x. And then negative 9 divided by 3 would be negative 3, so we would write minus 3. Now, this isn't quite in the exact form of y equals mx plus b, so I can flip it around. And then it is in the form of y equals mx plus b. So all three of those are linear equations. And then for this one, it says, explain how you would find the slope and y-intercept by just looking at the equation, and then graph the equation. So remember, m is our slope, and b is our y-intercept. And y equals mx plus b. So our slope here would be 1/3, and our y-intercept is that negative 2 because it's in the b spot. And then to graph this, quick drawing here, our y-intercept is negative 2, so on the y-axis we're going to put a dot at negative 2, and our slope is 1/3, so that means we're going to go up 1 and then over 3 to put our second point, and then we connect those dots and we have our graph. For this example, we need to find the slope of the line that passes through the points in the table. So again, it's given us 3 points. We only need to pick 2 of those to use, and it does not matter which 2 that you use. So I'm going to rewrite, the first one is -3, 5, and the second one is 0, 1. So I'm going to use those. And remember, I'm using y2 minus y1 over x2 minus x1. So y for my second point is 1, minus y for my first is 5. X out of the second point is 0, minus x out of the third is -3. So now I have minus a negative here, so that's going to cancel out and be a plus. We're going to add those two numbers. And 1 minus 5 is -4 on the top, and 0 plus 3 is 3 at the bottom. So the slope of this line is -4/3. And remember, we want to leave these in improper form because they're actually rise over run and they help us graph. So we don't want to make that -1 and 1/3 because that's not going to help us graph. Now we have to graph the points from the table and find the slope from the graph. So -3, 5 would be right here, over 0, up 1, and over 3, down 3 would be here. So now we can use rise over run from these points. So if I chose this point, I would have to come up here to this point. So I'm going to come up 1, 2, 3, 4. And then I have to go back 1, 2, 3. So I went that way 3 and I went up 4. Up 4 is positive, but left 3 would be negative. So that's still -4/3, which is what we got by finding using the slope formula above. Oops. Now we need to write an equation from the table. So we found out that the slope is -4/3. So far we know this much of our formula. So we're missing that b value, that y-intercept. So if we go back here and think about the y-intercept, we are looking for the point that crosses the y-axis. And at that point, the x is 0. So that value here is given to us in the table. It's at positive 1. So we can write y equals negative 4/3 x plus 1. So we can use that information given to create an equation. And then write an equation from the graph. So same thing. We figured out the rise over the run from the graph was negative 4/3. So we know that much. So we're looking for that b value again, that y-intercept. So if we look at the graph, where does it cross the y-axis? It crosses right here at positive 1. So then we can write plus 1 here for our b. And we have y equals mx plus b form. So a few different ways to take a look at things and figure out, but we end up still with the same result in the end.